So for today's agenda, I'm going to present the basic methods, post-training quantization and quantization-aware training, which are the main methods to perform quantization. And after that, we are going to get a more knowledge on specific architectures and their quantization impact. And at the end, I'm going to present you a personal workflow where we combine these two methods. So, first of all, before starting talking about post-training quantization, I want to ask you what quantization really is. And quantization basically is the process where we map the data from a high precision to a lower precision. And let's take, for example, floating point 32 to integrate. We do that because on the edge devices, we want our model to have the minimum size, so that is going to impact us very much. And also, when we have a quantized model and combining it with an NPU, basically we can target for a faster inference. Now, about quantization configuration, basically you can select a few options here. We can talk about symmetric versus asymmetric, where symmetric meaning that, let's say for example, you map the data from floating point 32 to integrate. Symmetric is meaning that for the new data range, you will get the data distribution centered in 0. But for the asymmetric part, basically it means that you are going to be, your data range is going to be centered in a variable called offset, which is one of the two quantization parameters, alongside with scale, but we'll talk about that later. Now, we can talk about per channel versus per tensor, and here we have per channel where you'll get a set of quantization parameters for each channel your input data has, and for per tensor, meaning that you'll have just one set of quantization parameters for the entire tensor. And now, dynamic versus static quantization, basically this means that you are going to, for the dynamic, you are going to compute the weights, to quantize the weights before the inference, and the activations will be, the quantization parameters for the activations, it will be computed during inference. Versus static, where basically you'll have everything computed before that.